Hello, everyone, and welcome to our session today with Asaya International, where we'll be speaking to how computer vision AI technology can benefit airports and airlines in these COVID times. I'd like to welcome in Christiaan Hen, he's the Chief Commercial Officer of Asaya, and Nikolay Kobyshev, the CTO of Asaya. And with that, I'd like to ask you both to turn your cameras and mics on, and we'll get the session underway. And if anybody does have questions, submit them in the chat on the side. This is recorded, but we'll have a team on hand to answer and address any questions as they come in. So with that, I'll let you guys take it away.
All right, thanks, Edward. So let's start at the beginning, Nikolay. You want to start with an introduction?
Yes, hello everyone. My name is Nikolay. I currently am a CTO and co-founder of Asaya. My background is mostly research in computer vision and AI. I participated in quite a lot of projects, and I also did quite a lot of education on that. I did my PhD and master's both in computer vision. Yeah, and over the last 3 or 4 years, I have gained quite a lot of understanding of how airports work as a system. So today I'm going to try to share my understanding of that with the audience.
Very cool, thanks. Hi everyone, thanks for joining. My name is Christiaan and I work as Chief Customer Officer at Asaya. Before joining Asaya about 2 years ago, I spent 8.5 years of my career at Amsterdam Airport Schiphol. That's actually where my love of aviation comes from. And when I met Nikolay and the other co-founders 2 years ago, I was super excited by what you guys were doing, and working at the airport for quite some time, I had a good understanding, and I really thought and still think that what we're doing actually is going to make a profound change in the industry. And so I was lucky enough that you guys were willing to have me, and I'm excited today that we got the chance to talk a little bit about what we do, and especially in the light of the current COVID crisis, how we can help airports and airlines weather this storm, because it's obviously a tough time for everyone. But before we go there, Nikolay, as one of the co-founders of Asaya, maybe you can tell us a little bit about how Asaya actually came into existence. How was the idea of the company born?
So it is actually a pretty straightforward story. So originally we knew that we're very big believers in technology. So we understand that artificial intelligence especially is something which actually will bring the technology to the next level. And it's not just sales words, but you really see once you start working with AI, you see it in action. You really realize that that's actually the way of moving stuff further. So we were essentially a team which had expertise in machine learning and in computer vision, just because of my background. And then we were looking for a relevant problem to solve, which is on one side a good problem for AI and computer vision, and on another side like a large enough problem to make the business attractive. And pretty soon we converged to the idea of using AI and computer vision for airports, not just for airports in general, but especially for the airside part of the airports. Because on one side, we saw that there is just not enough of data generated, not enough of sensed data. So there's a lot of stuff happening, but you cannot really monitor it properly. On another side, we saw that there is a huge optimization potential in a way that because you don't really know what's happening on the ground of your airport, you cannot really take proper operational decisions. It's very much based on human intuition, on some heuristics that people usually take in order to manage the process. But the problem is that the process is too complex. People are just not very efficient at managing it. That's why we kind of found a pretty nice fit for both technology and the business to work on this problem.
Cool, thanks. So maybe for the viewers who don't know us yet, to give a little bit of an introduction of what we do at Asaya. I think originally the company was very much founded as, I would almost say, a sensor company using computer vision to actually detect what is going on automatically and in real time during aircraft turnarounds. So we typically work preferably with existing cameras that are already present at the airport. They observe the aircraft turnaround, and the software that we develop then automatically creates timestamps for everything that happens during that turnaround. And this obviously addresses the sort of black box problem that Nikolay just talked about. And coming from the airport myself, it's almost like a bit kind of magic, because one of the things I liked about working at the airport is that there's so many stakeholders that have to work together to actually make an airport a success. Because obviously you got the airport, the airline, but you have fuelers, you have caterers, you have cleaners. There's literally tens, if not hundreds, of companies that are acting there. And the only way you can make it a success if everything works together. And everyone obviously plans for that, but as the day progresses, plans basically become useless as reality kicks in. And I think that's what we are trying to solve. We're trying to continuously create full visibility for everyone involved about what's happening, so that everyone can synchronize and organize their decision making and operations based on that. But I think, Nikolay, maybe you can tell us a little bit how we evolved from, I don't know, being a sensor company going more in towards the area of optimization that you just mentioned.
Yeah, so that's actually also pretty straightforward. I only answer straightforward questions today, or like I'm happy to, it's just
sorry for asking
story
questions.
No, this is actually very interesting. So we started indeed as a sensor company. We essentially thought, okay, we have computer vision, how we use it for something useful, and then we started installing our cameras using the existing cameras, which look at the plane during the turnaround and generating all this data. All this data is generated automatically, like when events start, when events happen, when some safety events happen, these kind of stuff. But then the more we were generating this data, the more we actually were also looking at it, we were analyzing it, and then we realized that the patterns of turnarounds, although it sounds like turnaround is a very straightforward process, there is like 20 actions and all of them have to happen, and then the plane will essentially leave. But all of them, each turnaround, is unique. It sounds pretty stupid and pretty ridiculous, but actually because there's so many different little processes, whenever one process gets delayed or gets wrong or someone forgets about that process, it all converges to essentially having a plane not leave on time, which is a huge problem. So we started looking at that. We started understanding with machine learning of what an optimal turnaround will be, what are the deviations of turnarounds which matter for plane being delayed, and which deviations from turnaround are actually perceived as a problem but are not a problem in reality because they actually don't affect anything. So we started looking at that, and we already found that it's a huge problem and a lot of stuff there can be analyzed further. Then, of course, a turnaround is just a part of an airport functioning, so we kind of zoomed into different gates, and then all the different problems which we can solve with all this information came. A classical and very simple example for that is standard location, because now having a holistic overview of the airport, you can actually optimize the entire ground operations, optimize how different players play together, like caterers and fuels and stuff like that, and of course also allocate planes properly. Yeah, so essentially going from a small niche problem to a larger problem in a very organic way, because we really see that there is more and more value for the data. That's why we apply it for more and more stuff. But we do it only for airports, so we're like very concentrated on this field.
Yeah, I think one of the surprises to me is that if you look on the superficial level, you could look at, I don't know, how long does catering or fueling take, and sometimes you already find a lot of interesting insights there. But if you have enough data, obviously you can compare, how long does, I don't know, catering take for on a specific day or on a specific part of the day at a shift. But what even more interesting is if you get more into the subtle details, where you see, for example, if catering at the front and loading bags in the front happens at the same time, that these operations actually have a very different sort of pattern than if they happen consecutively, which, it's pretty well explainable, because if everything needs to happen at the same time at the same place, then obviously people are in each other's way, and that affects these times that will eventually potentially also impact the total turnaround time. So it's always, I guess, a sort of bit of a search and a quest to sort of what can we find and what can we see in what's going on. And to be honest, it makes it quite exciting, I think. So to the point of optimization, like pre-COVID, to make the bridge to the title of this talk, pre-COVID, I think the aviation industry was in a state where capacity was, together with sustainability, probably the biggest talking points and the biggest problems that the industry had to solve. Now it seems that capacity cannot be a problem today because, you know, flights are down, I don't know, 70 to 90%, depending if you look internationally or domestic. And obviously cost cutting and efficiency in terms of cost efficiency are the big topics. And I think we'll get back to that. But I quickly wanted to hear, Nikolay, your opinion about sort of the relationship between the capacity topic and the COVID topic.
So it is a little bit, of course, that's very true, Chris. No one can deny that the aviation is in crisis and there's much less aircraft flying. And if you look at like Flight Radar, you'll see much less of these yellow little planes. However, the aircraft didn't really disappear, so now they're grounded. And I would not really say that the capacity problem is gone. Capacity problem is just like a different one, because for many airports, essentially everything which was flying is now grounded, and it also occupies the stands. So the first capacity issue is that airports just have less available stands because some of them are actually just blocked with parked aircraft. On another side, turnarounds have been prolonged because mainly because the aircraft has to be disinfected between the two flights. Mm-hmm. So each aircraft actually takes more time at the stand. So in a way, some of our customers actually experience very similar capacity problems as before. Yes, they have less planes, but they also have less stands and they have longer turnaround time. So the problem is actually very, very, very similar than it used to be. It's the same optimization problem as before.
Yeah. And that's actually something that we started internally calling the unintuitive truth, because it doesn't feel like capacity should be a problem, but as Nikolay just explained, you know, there's actually this line of argumentation that says that, you know, it could be a problem. And to that point, as we, you know, obviously see a lot of what is happening at different airports, we also started looking into that. And what's actually interesting that we found that turnaround times, they actually are much longer than they used to be. Again, due to sanitary measures in the terminal, to cleaning regimes, but also to parking, obviously. But it's not just the duration that became much longer, but it's also the variance in the turnaround times. So we can also see that, you know, operations are just much less stable. And if we then simulate, you know, what does that do? We have one case where you actually see it currently in the COVID situation, there's not an issue, and that planes arriving can actually directly go to a free stand. Pre-COVID, they were slightly capacity constrained. So, you know, there might be some cases where an aircraft would have to wait for a stand. And then we simulated all the cases in between. So what happens if you got 10% recovery, 20% recovery, 30% recovery? And then there's actually a sweet spot where we see that around
not sweet at all spot.
It's actually not a sweet spot. But there's like a peak where the effect of these longer turnaround times is not no longer canceled out by the fact that there's less aircraft, and that actually planes will have to, you know, wait for stands because the capacity is just not there. And that's a super interesting effect, I think. And to you, Nikolay, what do you think, you know, also from a mathematical perspective and optimization perspective, you know, what should airports be doing about this?
Yeah, so Chris has essentially put it correctly. When all the planes are flying, well, then we have the scenario which we used to observe before the crisis. So everything somehow works. When all the airplanes are grounded, there's also not a problem. But in between, when turnarounds are still long, but already more and more aircraft are coming, but you still have much less stands, that's where the problem is coming. And what I also wanted to highlight before I answer your question, Chris, is that this is somehow a typical property of just oversaturated system, or of a system where you have much less resources than you would need to have to deal with that. And this works like that. So these worst COVID scenarios, which we have modeled, where you have huge delays of planes arriving until they actually even get a stand position, is essentially pretty much the same as it will just happen in normal life, if the air traffic will just increase, because at some point the airports also run out of capacity. So the situation when the planes, in cases when the airport is so thin on capacity, one of the key problems is not only dealing with for example stand allocation or dealing with like turnaround sequencing, but also being able to predict whether when turnaround will finish, for example, so that you can take better decisions. And as Chris has said, the uncertainty has increased very much. So the data I just have on my phone with me now is that for one of the European airports, the standard deviation of a turnaround time before was around 50 minutes, long and short haul, and now it's 78 minutes. So it has multiplied almost by the factor of 2. And this happens because the turnarounds are held a bit differently now, and there is like a new reality. So one of the things I would suggest doing is actually employing AI and machine learning to predict when the turnaround will finish. Now, the main predictor for that is TOBT or similar metrics, which are essentially put by humans. Humans rely mainly on intuition and understanding of some kind of internal mental models. It has been proven, and we also have shown it in the company, that humans are not as good as machines for that, but especially for the new scenarios where human actually also doesn't have experience in turnarounds, which in COVID times, it's much more
situation.
It's a unique situation. No one has been there before. It's very, very hard to come up with a figure of how long the turnaround will last, not some kind of ballpark estimate, which people are doing now, but some really data proven decision. And that's what we're also trying to develop now to bring more and more airports to some kind of machine learning based predictors. And these predictors use, first of all the data about the flights, which you can use, like number of passengers, destination, and so on, but also the data which we generate about the turnaround itself. So we know when catering came, we know when fueling came, and so on. And this is actually very important data points to have a good prediction.
Nice. And I think that's also potentially a topic or a bridge to another topic that I do want to discuss here. Because besides, this unintuitive and capacity related story, I do think we also have to talk about costs, because every airline, every airport in the world is looking at cutting costs. And I think it's also our responsibility to try and help them with that. And on one side, it's interesting because if you have feeders or caterers and you have these unpredictable situations, they're probably not running as efficient as they could, right?
Exactly. Yeah, so that's exactly the truth. So if you have an airport with limited resources of, like, for example, fuelers and caterers, and not only what you plan to do with them, but you actually know the real situation with airports with some kind of prediction, so you know how will the airport look in 5 minutes or in 10 minutes or in an hour from now. It's an easy problem. Then you can just optimize for your resources, but once the predictions are thin in the air, you cannot really do that.
Yeah. And another thing that I find interesting is that for airlines it matters, of course, because if they're delayed, it costs money, and if they have people miss connections, it costs money. So I think airlines already today, they employ different ways to try and get control on what's happening. And one of those things is to employ a role that's either called a turnaround coordinator or an aircraft dispatch manager or something of the like. But it's typically someone who is at the turnaround physically, still very often, to actually manually observe what's going on, and if something falls behind schedule, to act. And this person is typically then sort of in charge of the overall turnaround. And I think it's quite exciting with several airline customers that we're currently working with, where we're actually trying to go to a remote turnaround concept. Actually, just like the remote tower concept, where the air traffic control from another location. If you have enough data and real-time visibility on what's happening at your turnaround, you don't have to have a single person per turnaround, and you can actually manage, 1, 2, 3, 4, 5, 10, 60 turnarounds with a few people from an operations room, for example. I think that's another case where, if you're looking into efficiencies, you can increase the productivity of these people, and basically make sure that you run your operations in a more efficient way. So we're almost out of time. Nikolay, is there any sort of closing remarks from your side, or anything else that you would like to give to the audience before we close it off?
Closing remarks. It's hard to say. So I think even without like, trying to sell our solution or like being, in conflict of interest, I have to say I observed this industry for many years now, and it's very, very, very clear that there is a huge potential of optimizing the resources that are currently used. And instead of, building more terminal buildings or employing more people or buying more equipment, wise and cheaper and more efficient decision would just to take the existing resources, try to get all the data available, and take some data-driven decisions, which will actually bring to high results. Yeah, I would say that's the main takeaway.
Cool. I have one last point, maybe, and it's actually something that you told me once, is if you're going to drive a car, you actually need your eyes to get feedback on what you're doing. And if someone would, close your eyes and tell you, okay, you need to drive straight for 30 seconds, then turn 90 degrees right for after 20 seconds, again left. That's basically the plan everyone makes for the day, right? But then reality changes. And I think that's how we kind of need to look at aviation as well. Like if we just plan and get out into an uncertain world, it's just going to get messy. So we need feedback, visual feedback. We need data about how we're doing.
Very strong feedback loops on every level.
Yeah, only then can we make the right decisions that will either address cost or capacity or any other of the objectives that airports and airlines have.
Yeah, thank you so much, Christiaan, Nikolay. Really great discussion and so interesting, and kind of just people have to be ready for what's ahead. So I really thank you guys both for your time, and to everybody joining us today. Please, visit SII's booth, and there's plenty of virtual meetings set up. Continue to network, continue to talk. But yeah, thank you guys so much for your time, and enjoy the rest of your day.